Most ocean waves are wind-generated. As wind passes over the water's surface, small ripples are formed, which eventually form fully developed waves due to the friction that is created between wind and surface water. As wind passes over the surface of the water, small fluctuations in the wind speed cause variations in the air pressure on the surface, which produce capillary waves. There are three main factors that influence wave growth: wind speed, wind duration, and fetch. For wind speed, the stronger the winds are, the larger the force, and therefore the bigger the wave. However, the wind must also be constant, and it can't just be a wind gust for a short period of time, which leads us to wind duration. The longer the wind blows over the open water, the larger the waves. Fetch is the distance of open water over which the wind blows. The longer the fetch, the larger the waves. The depth of the water also plays a role in wind growth, as it is difficult to generate large waves in shallow water. The friction on the water's surface allows for more energy to be transferred between waves, causing an increase in wave height. A fully developed sea is the maximum height of waves produced by conditions of wind speed, wind duration, and fetch. Waves originate in a sea area. A swell describes waves that have traveled out of their area of origination and exhibit a uniform and symmetrical shape. The amount of energy in a wave depends on its height and wavelength, as well as the distance over which it breaks. Swells are deep water waves, meaning that the depth of the water is greater than half the wave's wavelength. When these deep water waves move into shallower regions, they change into breaking waves. When the energy of the waves touches the ocean floor, the water particles drag along the bottom and flatten their orbit.
Circular orbital motion is when water moves in a circular fashion, first up and forward, then down, and then back to its nearby position. As a wave travels, the water passes the energy along by moving in a circular orbit. Orbital size decreases the depth to zero at wave base. Also, floating objects will follow circular orbits. The depth of a wave base is half wavelength, measured from still water level. Orbital motion pushes the waves forward. As waves move into shallow water, the bottom of a wave decreases speed. At a certain point, the top of the wave will overtake it and will break. When waves reach the shore, the energy at the front of the wave will slow down due to the friction with the shallow bottom. There are three types of wave breaks: spilling, plunging, and surging. The spilling breakers is when a gentle beach slope allows waves to disperse energy gradually. The plunging breakers is a moderately steep beach slope that gives waves a curling shape that propels surfers. The surging breakers is an abrupt beach slope that makes waves build up and break rapidly at the shore.
The difference between shallow and deep water waves is the ratio of the depth of the water to the wavelength of the wave. A wave changes from a deep water wave to a shallow water wave as the depth of the ocean decreases. Deep water waves have a wavelength that is more than half the depth. When the depth of the water becomes less than half of the wavelength, the wave becomes a shallow water wave. Additionally, deep water waves move in a circular orbit, while shallow water waves have a more elliptical pattern.
So this is one. Okay. So when you're completing one wave, this is its wavelength, and the highest point of the wave is amplitude. Okay, this amplitude is depending on its energy. Hello. And wavelength is depending of depth. So when deeper seas, wavelength is more than, is that narrow? No, please. What was the opposite of deep? Shallow, right? Yeah. Okay, shallow. Okay, you can cut this part. Okay, so this is the equation for the waves. This is period. Period is the time to make only one wave. So this is period. This is the velocity of the wave. It's been a long time to explain waves actually. Velocity of wave. And that means since period is not changing, if the sea is deeper, that means they will go with a big velocity. Does it make sense? Because when it's deeper, the wavelengths are bigger. That means the velocity of that point is bigger than if it's shallower. Did I say correct?
Yes.
Yeah.
Okay. That's the physics behind of the waves actually.